So determine whether a tangent line to a graph exists, and we're given the graph, and it's an absolute value graph. So let's plot some points, because we need to show graphically and numerically if the tangent line does not exist. So a table of values, let's have x and some y values. So if we had -2 and we substitute in -2 minus 1, -3, the absolute value is going to be positive. So if we substitute in -1, this is -1, -1 is -2, absolute value will be positive. If we substitute in 0, 0 minus 1 is going to be -1, which means it'll be +1. If we have 1, 1 minus 1 is going to be 0. If we substitute in 2, 2 minus 1 is 1, so it'll just be 1. And 3, 3 minus 1 is 2, so it'll be 2. And now if we sketch the graph, so let's do 1, 2, 3, -1, -2, -3, -1, we'll have 2 and 3, and okay, so -2, 3, and -1, 2, 0, 1, 1, 0, 2, 1, 3, 2. So this graph is going to do this. So we can look at this graph and we can say, well, actually, a tangent line was actually happening here. And if we were to draw or calculate, I said, the slope from the left, we've got a slope here of -2 and 2. So a slope m is -2/2, which is -1. And then if we did that this side, 2 and 2, so the slope m is going to be 2 divided by 2, which is 1. So we can see graphically that they have different slopes at the point of x is equal to 1. But let's have a look at this now numerically. So let's see what we can do. So the limit. So we're going to look at, because we're talking about at x is equal to 1, we're going to look at this when the limit is 0. So we need to look at both sides. And this is when x is 1. So we're going to use a plus h minus f of a divided by h. Now we need to substitute in the values. So our equation we have here, our f of x was equal to x, the absolute value of x minus 1. And we want to find this when a or x is going to be 1. So if we put this in, limit as h is approaching 0. So here we need to substitute in our value of 1. So we have 1 plus h minus f of 1 all over h. And now we're going to substitute this into our absolute value formula. So the limit, so we'll have, this is going to be as x, so we don't need f now. We're going to have 1 plus h, now we've got minus 1. So this is the absolute value, minus, and then we have again, so we have 1, 1 minus 1. So this is all over h. So if you simplify this, we have the ones will cancel. So these are going to cancel here, and this is going to be 0. So this is going to leave me with the absolute value of h minus 0 over h. So there's two things to know about the absolute value. So the absolute value of h, so if h is less than 0, so we'll have negative h is equal to absolute value. And if h is greater than 0, then we have h is equal to the absolute value. So if we look at this and we substitute it in, we'd have minus 1. So when it's negative, so if we look at it from the left, so the limit as h approaches 0 from the left, so this is going to be when it's negative. So our h over h, this is going to be minus h, which is going to be minus 1. If we look at our limit as h is approaching from the right, our limit is going to be positive, which is h over h, which is going to be 1. So a tangent line does not exist because the limits do not exist. And we can see, as said, from the graph, slope is negative 1 and slope is positive 1.